Okay, so guys, today I'm extremely sorry so that we couldn't connect today. So to speed up the process, I'm recording the whole session how linear regression works. Okay, to give you a brief how linear regression works is um, suppose you want to predict the sales uh, of your company for the next month. Okay, so suppose you have a transaction data, means you have the past data of your company and how much is the resource being used and what are the clients is giving a good business. Okay, on that terms you can predict the sales, okay, for your company. Okay, then there are a lot of things which will help you in doing in applying linear regression as a whole. Even in the stock market, you want to predict the stock of a company for the next 2 days. So then even you can apply linear regression in that point of time. So let me give you a brief how linear regression actually works. Is suppose I want to plot a point. Okay, so suppose this is my graph. Okay, so this is x. So what is the example we are looking for is suppose I have a couple of points. Let's say we want to predict the price of the petrol on which is dependent on the distance. These are some random values I put in here. Okay, so these are some of the points will be. So these are the points. Suppose you travel a distance of 10 kilometer and you have a paid a price of 30 rupees. Okay, and again if you travel a distance of 12 kilometer, you are giving a price of 350 rupees. And this is the basic. I've generated these points randomly. Okay, so these are not actual data set. We'll be working on actual data set, and even I've saved a full resource or notebook how to do linear regression using Python code. Okay, so suppose this is a independent variable. What is the independent variable? That the distance is fixed, it doesn't depend on on any other dependent variable. Okay, and y is a dependent variable, means this will vary according to x. Okay, so it is dependent on x. So we'll try to plot these things. Okay, so this is my point. Okay, suppose I have a point here, 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 I have a point here. So these are randomly I have generated this data set. Okay, so I will explain this thing in a very lucid way, means so that you can grab. Suppose I want to predict a point when x equals to, suppose I take it as a 17 kilometer. Okay, so what would be the price if I travel 17 kilometer? How much price you have to give for y? Okay, we want to fit a line, means this is the arbitrary line, means this is the regression line which runs through it. So this is the regression line y pred. Okay, so this is my y pred, and this is my actual y. So this, if you can see this line doesn't goes through each and every point, means there is some difference, right? So but I will try to, this will try to fit all the points here. So what happens is there is an error here, means this line differs from the actual y, means if you can consider this is the y. Okay, if this is the y, I mention is y I, suppose this is y I plus 1. So this line differs, means this is the y predicted line and this is the actual y what we are getting. Means suppose this is xi plus 1, comma y I plus 1. Okay, so this line is a difference, there is a difference in what is the actual y and what the regression line has predicted. So this error in the line is called the residuals. This is the residuals. So we have to minimize every in every equation in a machine learning. Okay, there is called a cost function and we have to minimize the cost function, we have to minimize the error. Okay, so how best we can fit this line? So what the linear regression have a actual definition, means how closely it can fit all the predicted points is what we want to define from the line itself. Okay, so these are the residuals, means this is the error, means the line hasn't predicted well. Okay, so what we will see what mean square error is, means how mean square occurs. The algorithm works as this one. So what is the y is equal to a plus beta x. Okay, so a is here the coefficient and b is the slope. So if we point all this point, okay, so y pred y dash error, if we want to say this is error equals to y actual y minus y pred. Okay, mean square error equals to, this is very simple formula, square of error square of error by n. Okay, so this is mean square error. So what assumption what we can bring here is very lower the mean square error, means the line has a good fit with all the points. Okay, if the mean square error is a very high, means the line which we have predicted is not a good fit to all the points. So how we can calculate it? Okay, so we can calculate with a simple example of this what we have taken. So find the regression line, insert x in all the points and predict the y point. Okay, then subtract y from the origin, square the error and add up the error and find the mean. Suppose I want to plot these points. Okay, let's calculate it. We copy this thing and I want to generate a graph with this point. So the equation what we have got is this one. This is the regression line. What I will do here is I will put all the x here, and this is y pred. Y pred. I will put all the x here, means all the x value will be here, equals to I'm plotting all the points of y pred. Okay. So what we have done is, this is the regression line what we have got. We have replaced x with all the x point, okay, and we are predicting the point. This is the y pred. So you can see here that the actual y was 30, it has deferred to 296. The actual y was 350, it has predicted as 259. So there is an error, means difference between the actual y and the y pred. So what is the difference? So I will calculate the error here. Okay, so the error is y actual minus y pred. Okay, so we'll get a certain value here. So if we calculate it, the difference so what we get is the difference from this point. There's some residual value, I have optimized it to the nearest point. Okay, so this is the actual y pred what we are getting. So but from here, what next step is, I will square each and every point. So after squaring, means square of every error in so if you square all the errors, it is coming up this thing. Okay, so what is the actual summation? This is summation. So if you sum all this thing, That is coming to 1. You see here 1671. 0.54 means 1672. I can take 161672. So this is the summation of all there. What we have done, we have put a regression line from the graph, okay, and we have replaced all the x with the corresponding value, okay. So this is 10 replaced by 10, x replaced by so all the values I have replaced here, and this is the actual value what I have summed up, but there were some decimals which I've opted from here. So this is the error means difference between the actual y and the what y has actually predicted, and after squaring it we get this value, okay, and we do a summation. And what is the mean square error? Mean square error is mean square error is summation of all the square by n. Summation of all the square, summation of all square error by n. So if we divided it by 8, 16672 divided by 8, so we'll get the value, and it's come around to 209. So this is the mean square error. So let me repeat it. As linear regression, I'm gonna give you a summarize of how linear regression works. Linear regression is a very simple algorithm which is being used in predicting or forecasting sales or a continuous value. What is depends on? It depends on a dependent variable and have some independent variable. Linear regression, the independent variable is 1, okay. So we have x, you want to predict the price of a petrol if you have traveled some distance on basis of a regression line. What I have done, I have replaced, this is the equation of the line what we have got from this plot. From this plot we have got a regression line. This is a regression line, okay. So what I have done here, I have replaced all the x with the corresponding value of x with the regression line, and this is what we get the y pred. What I have done, this you can interestingly see that there is an error, means actually there is a difference between the actual y and the what y has actually predicted. So there is an error, so we have to minimize this error. Okay, so with how to minimize the error, we'll cover it in the gradient descent and how gradient descent can optimize this error and give a best fit to the line. We'll discuss in the later section, so let us concentrate on this point. So what I have done, I have make a difference of actual y and the y pred, and this is the value. I square all the values, means squaring 4 into 4, this 17 comes, 9 into 9, this one's come. So what I've done, I've made a square of all the values, then squaring all the values I am doing a summation, okay. Summation 16972 is the summation. So after dividing, what is mean square error? Summation of all the square error divided by n, we get a mean square error. So this is as simple as this. More if the value is 209, when say if we can see that is a huge error in this line, so it's not a good fit, and we'll try to optimize it using gradient descent in a later section, okay. So what you can predict means this is not a good fit to the line, and we have to optimize it. That's square mean error and how linear regression works. Thank you.